So then the point cloud data, after generating that orthorectified images, after generating that the DSM. So what does it mean, the DSM DM? So as I said, that the point cloud data will give that, each points will give that XYZ informations, right? So I just want to see the real world, the surface models. What I can do, there are some options in the softwares, like I just want to create the surface model. So how that surface model will create, it will take the elevation, the nearest elevations values or nearest XYZ values, it will be triangular to each other. So because I have that 1 billion points of, or billions of points or millions of points, so I can easily triangulate that surface, and then I can easily visualize. So you can see it is looks very very smooth surfaces. When I zoom in, so you can see that each and every triangle, so you can see that. So the left image is DSM overlay with the artifact images. The right side DSM or DEM or DTM with the contours. So accuracy and applications. The next slides I'm going to cover. So as I say that, like, accuracy is very very important, because the people are going to use for like the natural calamities application, for like the flood analysis, for urban planning, forestry mapping. So for that accuracy, how it is important. So typically, like we can get that absolute vertical accuracy of plus or minus 10 meters, uh, and horizontal accuracy of zero point 0.5 meters. So this accuracy also, it depends. It depends on that how many satellites are available, and what are the base values we have used, and it depends. It depends on the site conditions, right? And after done with the data acquisition part, it will come to that that backend process for the data processing. They are also might be using a lot of GNSS softwares for correcting, for rectifying the issues, and DGPS softwares, and they will use for the data post processes after like a microstation TerraSolid products. So uh, after the the data acquisition for the data processing part, ultimately the LiDAR technologies will give the accuracy of like a plus or minus 10 meter, and plus or minus the 5.05 meters. So this in the airborne LiDAR survey. So when we are going to that using that drone technologies, we can achieve the accuracy of the same kind of things for the mobile LiDAR survey and terrestrial LiDAR survey. So that's what the people are preferring to go with, that these LiDAR technologies, especially for the EPC industries, like transmission line projects, railway projects, or roads projects. So now I hope you might understand like why the people are going with that the LiDAR technologies instead of the photogrammetry and the remote sensing technologies. So as I said that, what are the applications are going to be, what are the applications going to be there by using the LiDAR technologies? The first one is the flood risk mapping, and corridor mapping, road and rail, and utility mapping like a power line, pipeline, and the forestry, urban, wetland mapping, coastal zone mapping. So based on that application, so let's say I just want to go for the flood risk mapping. So what kind of technologies I need to use, means what kind of types of survey I have to use. Obviously I will prefer that airborne LiDAR survey, because I just want to cover the more area. For that I just want to go with that airborne LiDAR survey only. Or else, if the areas are very small, then I can prefer to go for the drone LiDAR survey, because the flood risk analysis, I need very precise and very highly accurate data. So this is based on that applications. The users can take up a call, and they can choose the types of survey, and they can go for, and they can choose the sensors as well. So as I said that, like, there are two different parts are will be involved in these technologies. One is the data acquisition part, and second one is the data processing. So for the data processing, what are the softwares that people are using? So the majorly the people are using that Bentley microstation and TerraSolid products. So this is the backbone softwares for the for airborne LiDAR data processing, or mobile LiDAR data processing, or for point cloud classification, or 3D vector mapping extractions. The people used to prefer these softwares. So this is like, as I said, that TerraSolid, it is a product. There are so many modules, sub modules are available in the TerraSolid. It's like a 16, 17 sub modules are there. So majorly the people are using the TerraScan, TerraModel, TerraMatch, and TerraPhotos. So what is that? What are these modules? Though TerraScan is mainly using for the viewing that point cloud data. right? There are so many tools are there for I have shown you that the 2 3 slides before. I want to see that data in by intensity mode, by elevation mode, or by color mode. So there are some tools are available in the terrascan. We can visualize the data. So terrascan is only useful for the visualizing the point cloud data. So Terra model for editing the point cloud data. As I said that the point cloud data, it is having the only one class like a default classes. I want to classify in different classes. Let's say I want to classify the data into like to segregate in that vegetation, like a low vegetation, high vegetation, medium vegetation, and then settlements like a buildings and power lines and roads. So for that, we can use the Terra model modules for editing the point cloud data, and then Terra match. So Terramatch is mainly useful for the data calibration. So when we are flying that aircraft or drones, there will be some mismatch of the between the two flights. So I just wants to make the two flights in the same level. For that, the Terramatch modules is using. So this is a very critical and critical task in that airborne lidar and drone lidar technologies. The person should have very highly skilled to do this process, means the data calibration process. And the same thing like for the teraphoto for aerial triangulation process. So when the aircraft it is covering the means it is capturing the aerial images, it gives some it gives some precise let's say like 50 centimeter 1 meter difference deviations that images. So how to correct it, how to correct that images, and how to get the very precise information with the ground truth. So for that, there is a modules called Terraphoto. So we can do that camera calibration, and we can do that ortho rectified images, and we can easily generate the ortho rectified images from the Terraphoto modules. So once you are going for the training, the further training uh, about these like LiDAR technologies, so you can go for the each and every tool separately, and you can see that like how it is that tools are working, how the systems or how the softwares are working in the back end. So you can understand very easily. As I said, that the type of work what we can do by using the airborne LiDAR survey or mobile LiDAR survey, drone with the LiDAR survey. So first one thing is the like a flight line calibration and bore side calibration and terra match, right? So you can see that what are the types of survey they have used. They use it for airborne and mobile radar. So these two surveys are very similar, as I said before, like the data capturing method and data processing method. But the way we are looking the data, it is totally different. And then we can do the data classification, airborne, mobile data, TLS, and drone data, and aerial triangulations for airborne. We can airborne data survey data. We can do that. So medium format of the camera. So they will already predefine the camera settings in that like a teraphoto modules. We can choose any one of the camera which we have used for the data acquisition time, and then we can easily generate the DEM and DSM products. What does mean the DEM and DSM? What is the difference between these two? DEM is like a digital elevation models which will you give the only the ground information. DSM, it will give you that all the information which is included in that, like trees, settlements, power lines, all the man-made features will be included. So that is called DSM. So for what are the inputs we are required? Means what are the inputs we will get it from the airborne LiDAR survey or from the LiDAR technology. First, we will get that raw laser data, right, which is in the format of LAS, BI, and FPI format. And then flight line path, as I said, that trajectory, it is very, very important. Without trajectories, we cannot do any further process. So trajectory is very, very important, because in the trajectory, that timestamp value will be stored. So how it is combined means how it is like synchronizing the raw laser data and the trajectory. The mediator is the timestamp. If you lost your timestamps in the laser means in the LiDAR data, you cannot use the LiDAR data. If you lost any like a timestamp value in the trajectory, so you cannot use the further any process like a data calibration, data classification, and generate the outputs. So if you want to improve that, if you want to improve our data accuracy, obviously ground control points is required. And if you want to justify our data accuracy, for that also we need the ground control points. Let's say we can tell to that the client or to the customers, I have achieved the accuracy of like a 10 centimeter or zero point 0.1 zero point 0.1 meter in that XY, and that jet is that like 15 centimeter or 0.15 meter. they will ask you like how you justify, how you can say that, like that time we can use our the control points on the base station points, then we can overlay these points and we can tell them like this is the accuracy which we have achieved. So when then we can ask them if you have any reference points, you just provide us, then we can show you that. And then project boundary. So project boundary, it's like as I said that like if you are going for 10 per kilometer, 100 per kilometer, 1,000 square kilometer, it will give you the some the boundary line, the area boundary line that it might having in the GGN format, PWG format, DXF format, or CFL format, whatever. So we can easily interpolate these file formats into that anyone. Like if I have received that the input file in the DWG format, I can easily convert it to the CFL RPG by using the microstation, by using the global mapper or whatever it is. And then we will prepare the tile index. Why this tile index is required? So let's say I have the 1,000 square kilometer data. If I open the 1,000 square kilometer data at a time, is it possible? The data size will be in the TB, right? So for that, in a single file, I just want to create in the multiple files, which is compatible with the softwares or with our systems. Let's say I'm having 1,000 square kilometer. I'm going to create zero point 0.5 square kilometer grid for the tile, and that 0.5 square kilometer or 1 square kilometer the data I can easily open the data in the software, where the software can give means the software will support us and our systems also will support us. So there won't be any hang, there won't be any crash will happen. So all the projections informations will be stored in that project boundary files and the trajectory files, and then the tile index like which we are going to create the small tiles files, that in all that files the projections informations will be stored. So I just want to tell you one important points, like if you don't know that the projections information, so you can easily open that the DGN or shapefile into that Google Earth, and you can come to know that like what is the projections that people have used. So this is kind of like a tips and tricks, like how to identify the data, and if there is any issues to identify the information, the particular data, so you can easily come to know that. And for the inputs for point cloud data classification, so what are the files we record? As you have seen that like for lesser point cloud data, and then project boundary, and the tile files, and then projections information, and the specification document which we have get it from the clients or customers. Based on that we will go for the classification. So the pointless definitions file in the PDC format. This might be optional, or we require these PDC files where we can create these PDC files and PRJ files in the TerraScan or Terra model. So we can use and we can create that PDC. So what will we carry that PDC files, like a PDC which is having the different classes, like point number one, it is having the building class. Point number two, it is having that vegetation. Point number three, it is having the power line. So all the informations will be stored in that point class file, PDC file. So you can open the PDC file, it will be directly classify the data into that format. And project definitions file in PRJ format, that is also we can easily generate it, means we can create it from the TerraScan by using the TerraSolid products. So what are the inputs for the required for the aerial triangulations? So we need raw images, which is having in the TIFF format or ECW or JPG format, and then project boundary and the tile index. So what does it mean, the GSD? GSD means it's like ground sample distance value, which it is going to give our ground truth values. Let's say I'm going to get the GSD values of 1 centimeter, 10 centimeter. The pixels will be generated, or the pixel resolutions will be in the 0.5 centimeter. Like what we are going to define that values, like a 10 centimeter or 0.5 centimeter. And we need the trajectory files for that, for synchronize the raw images, and then the trajectory and projection information ultimately we get it. And image list IML files are record, highly record this image list, because each image is having the information like the image ID and the XYZ and interior parameters, exterior parameters, that will be stored in the IML. So this IML camera calibration file and the ground control points, we will get it from the clients, or we will get it from the customers. So this is like these are the inputs data are record for the aerial triangulation for the data class. So now I'm going to showcase of that like a sample data. What are the sample data? So you can see the sample data of the transmission line projects. So see the blue colors or towers or substation. The yellow colors it is indicating the building, right? So the color, the blue light blue color, it is having the power line, right? And the green color it is the vegetation area. So these are the the data classifications parts will be involved, and we can classify each and every features by using the TerraSolid products. And then we can do that 3D power line vectorization, and we can do that data like a danger point analysis. So if you are interested to learn the things like you can go for Google it and you can join the training session, and I will explain you how to do that classification, how to do that mapping vectorization, how to do the danger point analysis, and how to create the danger point analysis report. So those are all the informations are available in the TerraSolid products. Now you can see that. So I just forgot to ask you that while you are seeing this data, you might you will come to know like what kind of surveys they may use, and what kind of sensors they may use, and what kind of means instruments they may use. Obviously, they have done this survey by using the aircraft by using the aircraft lidar. So they covered the area that in the linear format. Now you can see that the sample data of railway and the infrastructure, I mean the road projects. All right. So while seeing this data, you can imagine or you can say from yourself like, okay, this data can be might be captured from the mobile lidar. Yes, of course, this data can have been captured by using the mobile lidar instruments. So you can see the elevations based on the elevations informations. The data it looks like, and this is the intensity. Intensity is having only the two informations. One is the black and white, 0 or 1. So these data have been captured from the terrestrial LiDAR scanners. So as I said that from the terrestrial LiDAR scanners, we can create the 3D modeling. We can create the 3D vector mapping with the LOD level of 0, 1, 2, 3, 4, 5, whatever we want. We can. What does it mean that LOD? LOD means it's a level of details. What kind of level of details we are required. So that it is indicating that it is mean that LOD. So you can see the point cloud data with elevation. So why I just kept these snapshots, you can see uh, it is the very dense vegetation places, but you can see that the ground profile how it is, the nature of the ground how it is looks like. That is the big advantages of using that the airborne lidar technologies. So you cannot get it kind of this kind of profiles which by using any other technologies, let's say photogrammetry or remote sensing. Yes, you know that remote sensing will give not you the information, but we can use the photogrammetry technologies, but from the stereo images we can generate the digital elevation model, but that DEM it will not give the the ground profile looks like this. So that's what people are preferring to go for that, LiDAR technologies and using that airborne LiDAR, mobile LiDAR. So this is the sample data which is derived from that, that drones using the RGB sensors. So it is very small areas. They just want to see the how that the oil and gas plantations over there. So they have done the survey of like a 0.25 square kilometer or whatever. So they have generated the DSM and the DEM. So you can see the difference between these two. The DEM it's having only that the ground information, right? And then you can see that DSM it is having all the information which you are seeing the same that the authoritative image. So by visualizing that image itself, you can compare it yourself, and you can you can clear yourself what is the difference between DEM and DSM. So there are another one like models, surface models are there that is called a digital terrain model. So what is the difference between digital terrain model and digital elevation model? So digital elevation, digital terrain model is very similar, where I can use that break lines and to generate that by using the break lines to generate that like a surface model that is called digital terrain model. So I can show you that step by step slopes in the digital terrain model. So what are the advantages are there by using the LiDAR survey? So data can be captured quickly and accurately. LiDAR is an airborne sensing technology that accelerates the speed of data collections while also providing extremely high accuracy due to its positioning advantage. So let's say I just want to cover the 1,000 square kilometer. Do you think it can be completed within 10 to 15 days? Yes, it is possible to complete the data data acquisition part for the 10,000 square kilometer within a 10 to 15 days. If that weathers are supporting, like if there is no any the rainy seasons or winter seasons or like a snowfall season, we can easily cover that 1,000 square kilometer in a like a 10 to 15 days. And surface data has a higher sample density better than the photogrammetry. So as I say that in the single lesser pulses will give you that 3 to 5 returns, right? So in single pulses or in single pulses uh, uh, pertaining that the ground which is having the point square meter like 1.01 square meter, it will be like 40 points density and capable of gathering elevation data in a dense forest. You have seen that the previous images, the natural the ground profile and with the dense forest area. So that is the bigger advantages by using the airborne LiDAR technology. And it can be used day and night because these technologies are using the active sensor, so it is not record the sunlight, as you know that. It is not affected by light variations such as the darkness and light. Yes, obviously we cannot go for that, the LiDAR survey in the night time, whereas the light powers like the natural powers are not there. So unlike other types of data collection, LiDAR sensors are unaffected by geometrical distortions such as angular landscapes. It can be integrated with other data sources. Yes, obviously we can use this data with a we can convert to the different data sources, and it can be compatible with the different software that we can use it. It has a minimum human dependence. Yes. So when we are going for the conventional survey methods, obviously for covering the 1 square kilometer, we record like 5 to 10 people to go to the field and to capture it. So it's a minimum record like a pilot and co-pilot to the data acquisition part and the data processing. It depends like what are the outputs or what are the products we are going to be generated. It's based on that like the human in the resource will be vary. And what are the disadvantages? Obviously, if you are going for technologies, will be like positive sides as well as the negative sides. So what are the disadvantages of using the LiDAR survey? High operating cost in some applications. Yeah, if I ask them to the vendors, I want to I need the data in millimeter, like accuracy or 1 centimeter accuracy. Obviously, for that they will make a very perfect flight planning and they will establish that base stations in like 24 hours or 48 hours. For that, obviously, that operating cost will be vary based on that application, or based on that client requirements. It is ineffective during heavy rain and low hanging clouds. Yes, obviously, these are the electronic equipment. So when it is the rainy season, so definitely we cannot use that the instruments for the survey. So this model is unreliable for water depth and turbulent breaking waves. Yes, the laser pulses will not be heated to that the water, and it will not penetrate, and it will not give that what is the exact ground on the water in depth water area. So for that, the people are using in the different technology survey technology that is called a mathematic LiDAR survey, which is working in that beam method, like a beam process methodology. So data sets that are extremely huge and difficult to interpret. Yes, obviously. So the data size will be in like a TB. So when I was working in that LiDAR data in 2008, 2010, the data handling like uploading the data from the server, and we are once done the work and we are uploading that data in the FTP. It was a very huge challenging part was happened at the time. Now the people are working the very smart, like they are compress the data size into GP to the MB, like let's say 1 GB data now it comes in the like 100 MB. We can open that LAZ file format in any other software, like in the MicroStation or in Rhinoceros in Civil 3D software. No international protocols. Yes, there are no strict international protocols that guide that collection and analysis of the data when using LiDAR technology. Hence, it is done haphazardly, and I have done my that. It's almost covered. I hope you might understand and you have get a very clear idea about the LiDAR technologies and what are the types of LiDAR and how the data it looks like and how the data can be used for the different applications.